In this section, we are going to talk about enums and patterns. Enums are going to allow us to define a type with its possible variants, and patterns are going to allow us to execute code based on specific logic being true. Matching is a very powerful tool Rust gives us, so I'm excited to be able to show this to you as we continue on through this section. Enumerations, or enums for short, allow you to define a type by enumerating its possible variants. So let's start by looking at how to define an enum. So it's relatively the same as a struct, so we'll say enum, and then we'll create an enumeration of pets, so we'll call it pet, and then we'll open and close it with curly brackets, and then in here we'll have a dog, a cat, and a fish. So to use this, then we can just say let dog equals pet of dog. So just like structs, we can also implement methods on them. So let's impl pet, open and close, and then let's create a function called what am I. And remember, you have to reference yourself, and then we're going to return a string slice, and then inside here we're just going to say hey match, and we'll get into this in a second, self pet dog, I need to capitalize the P, pet dog, and if it matches, return I am a dog. And then we're going to do this again for cat and fish. So there is something that I purposefully left out, so let's see what it is. It says we are expecting a string, but we returned a string slice. Okay, so now let's return a reference to our string slice. But now when we do that, we need to specify our lifetime annotation, and we want it to be a static lifetime. So now we're all good. So down here, let's print this out just to make sure everything worked. So we're going to have a dog, and we're going to say, what am I? So we're expecting it to say, I am a dog. And that's exactly what it says. It says, I am a dog. So awesome. It worked. So we can also do that for cat and fish, and they would return, I am a cat, I am a fish. But now let's look at how we can use an enum inside of a struct. So we're going to shift gears for a second. We're going to create another enum called IP adder kind, so the IP address kind. And we're going to have IPv4 and then also 6. So now inside of here, we're going to create a struct for IP address. And for our kind, we're going to assign it an IP adder kind, because our IP can either be IPv4 or IPv6. And then our address is obviously going to be a string. So down here, let's say let home equal IP adder, and it's going, the kind is going to be IP adder kind v4, and then our address is going to be a string from 127.0.0.1, so localhost. And close it. So we can also do let loopback IP adder kind IP adder kind, and in this case it's going to be version 6, and then our address is going to be that. So that's how we can use an enum inside of a struct. We can also have structs inside of enums, and then furthermore we can assign data types inside our enum as well. So let's say we have this up here, so we're going to assign a data type to it, and we want this to be a string. So down here we can modify, we'll say let home equals IP adder v4, and then we need it to be a string. So then we have string from 127.0.0.1. So we have a little error. Let's see what it says. No associated name, and that's because this needs to say kind. So that's how we can assign a type inside of our enum. So you can get creative as you want with types inside of an enum. You can have variants with no data associated, named fields like a struct. You can specify a string or specify as many types inside just like you can with a tuple. So the options are quite extensive, which is great. So now let's look at some enums that Rust gives us by default. The option enum is important because it allows us to either allow a value to be something or it could be nothing. The nothing aspect is comparable to null in other languages, whereas Rust does not have the null feature, it just uses none inside the option enum. So let's look to see how the option enum is set up. So we have enum option of a generic t, which we will learn about in the next section. And then inside this enum we have none, and then we have some t. And that's all there is to it, to the option enum. The t means it is generic, which, as I said, we will cover in the next section. But to simply put it, it can hold a piece of data of any type. You do not have to do anything in order to use this option enum, as it is already available inside the scope for us already. So I can delete all of this, and then in here we can say let some number equals sum 5, and just to make it clean it up. Let some string, and this is going to be a reference to a string slice, but a string. And then we can say let nothing equal of an option, and we'll specify that it's also an I8 equals none. So all of these are valid, and it is important to know that option t, so what we have here, this is the same thing as saying we're declaring the type, but behind the scenes, before we say it's an I8, it is option t, whereas let x equals 5 is equal to an I32. So I guess just to really clarify this, let's make that an I32. These two, when we declare option I32 and then we declare a variable to have 5, which is I32 by default, these are not the same. So we can show this by saying let x of I32 equal to 5, and then it will say let y of option I32 also equal to 5. And it helps if I put the sum keyword. So now if we try to add these, let sum equals to x plus y, we see we get an error, and it says we cannot add option of I32 to I32. So you would have to convert the option of I32 to an I32 before we could perform this operation. So to wrap up what an option enum is, and when we want to use it, we would want some code that would run, but only when we have some t. And then that code uses the inner t, and remember, t is the data type. We would also want code to handle the case of when we have none. So we want code that can be able to handle something or nothing. Well, luckily for us, Rust gives us the match expression, which is a control flow construct that does exactly this when we use it with enums. So let's take a look at how that match statement works in the next lecture. Match is going to do exactly what it sounds like it will do. It is going to allow us to compare a value against a series of patterns and then execute code based on the matching pattern. So we did it earlier in one of our examples when we were setting up a pet enum. And what we did was basically said, hey, match on yourself, and if you're a dog, I want you to print out, I am a dog. So in essence, that's what the match statement does. So let's create another example, and we'll create a new function called fn plus 1. And we're going to take in an option I32, and we want to return an option of type I32. And then in here, we're going to say we want to match on X. If none is passed in, then that's what we want to return, none. But if something is passed in, then we want to return sum of I plus 1. So when we run this, or call this, I should say, we'll say let 5 equals sum I, right? So this is essentially what's going to get converted to sum 5 right there, that's sum of I. And then we say let 6 equals plus 1 of 5. And then we'll say let none equals plus 1 of none. And then let's print it out. So we'll print it out. And we'll have 6 in here. And it's probably going to want it to be just like that. Okay? Go back to the terminal. Cargo, run it, and that's exactly what we got returned, was sum 6. So now if we come back in here and we do none, we would expect none to be returned. And that's exactly what happened. So what this function did was it accepted a parameter of x, which we passed in here was 5, and then inside of the 5 variable contained sum 5. And we matched on sum of I, so any value could have been passed in here, and then whatever the value that sum contained, we added 1 to it. So what happens if we forget to add in the num statement? We already see we get an error coming. So it says we got an error. Okay, pattern none not covered. So the compiler will catch it for us. Matches in Rust are exhaustive, meaning that every possibility must be exhausted for the code to be valid. So we need to make sure that we cover every case, because otherwise it will likely introduce a bug into our code. So we can use catch-all patterns to be able to handle all other situations. So let me come back in here and we'll just re-put in none. And then let's go back and look at our pet enum and show that for all other pets, we will print out something different. So we want to come up here and actually, we'll come down here and we'll create a function that says what pet. And then in here, we'll take our input, which is going to be a reference to a string slice, and then we don't need to return anything in this case, but we're going to match on input. So what we'll do in here is we'll say, hey, we have dog, and we're going to return I have a dog. And then for all of our other cases, we'll have our fish, we'll have our cat, and then we can see that our input is already kind of like hinting to us, hey, something needs to be covered. So if we hover over it, it'll tell us the non-exhaustive pattern is not covered, and it's telling us to use an underscore. So if we put in an underscore here and then just say, hey, I have no clue what pet you have. Well, now it seems to work because we're using this underscore to cover all other situations. So now let's test this out real quick. We'll say what pet, and we'll say dog. What pet? Cat. What pet? And cow. So now if we run this, we expect to see I have a dog, I have a cat, and I have no clue what pet you have. And that's exactly what we got. So it's important to remember that match is exhaustive. So we have to try to cover every single case that we could have. And then we can use this little underscore right here to basically say, hey, if it doesn't match anything else, then by default, run this. We can use if-let statements as a shorter way to write the equivalent of a match that only matches one case. Optionally, if-let can have an else containing code to run if the pattern in the if-let does not match. So, a super simple example, we'll say let dog2 is equal to some pet that is a dog. And then if-let some pet that is a dog equals dog2, we will print out the animal is a dog, but if it's not a dog, then we'll print out not a dog. So what's going on in here? So we're basically saying, hey, if some pet is a dog, right? So this is the type we're looking for. And then we created in dog2 the same type. So if it matches, print out the animal is a dog. Otherwise, it's not a dog. So we know that this is going to print out the animal is a dog. But if we happen to make it a cat, well, then we would expect the match up here to not match. And we would expect it to print not a dog, which is what happens. So you can also, extend this with else if and else if let statements. So it all works the same as if we were just doing regular control flow statements. So we can also extend this, or we can also use while let loops. So let's create a stack, and we'll call it a new vector. And then what we'll do is we'll put in a couple of values. And we'll change these to different numbers. And now we'll execute a while let sum top equals stack.pop print out top. So what's going on here? So we created a new vector, pushed in 3 values of 1, 2, and 3, and then we're saying, hey, pop the stack, and then while it is some number, which in this case it'll be sum 1, sum 2, sum 3, so while it is some number, we want to print out that number that is being taken off the stack. And what do we get? We get 3, 2, 1. And that is because stacks are last in, first out. So I just wanted to show you these quick examples of other ways that we can use if let examples or while let in order to match on single statements and then execute some code based on those match statements. So in this lecture, I want to look at how and where we can use just additional patterns and the type of syntaxes we have available to us. So there are many different syntaxes and ways that we can create a match arm, but I just want to introduce you to a few just to kind of show you what all is available to us. So let's create a variable x and assign it to 1. And then we're going to match on x. And then inside here, we want to say 1 or 2. So if the value of x is 1 or 2, then we want to print out 1 or 2. And then to make our match exhaustive, we want to say anything else, let's print out not 1 or 2. So when we run this, with x being 1, we expect it to print out 1 or 2, which is exactly what happens. And then just to verify that we are getting the desired behavior, change x to 10 and rerun it, and we see that we get not 1 or 2. So this syntax up here with this operator is the OR call, the OR operator, I should say. And what it's doing is it is saying, hey, if x is 1 or 2, then this statement is true, so execute the following code, which is exactly what happened. So let's comment that out and let's look at a different way. So now we're going to match on an inclusive range of values. So we'll leave x is equal to 10. We'll match on x again. And in this case, we'll say 1 to 5. And if it matches in that range, we'll print out matches. Otherwise, we're going to print out not matching. So we see that we got our little red squiggly. Let's check out what it says. It is telling us the exclusive range pattern is experimental. So to fix this, we need to add in the little equal sign. So now it's going to be 1 to 5, which includes 5. So with our x being 10, we expect this to print out not matching. But when we go to 5, I anticipate it saying that it matches, which is exactly what happens. So this is how we can use an inclusive range to check over a range of values to see if something matches. And then lastly, we can use an if condition specified after the pattern and a match. So let's check this out. So let's say let x equals to sum 5. And then we'll say let y equals 5. And then we're going to match on x. And we'll say sum 10. And then we're going to print out 10. Okay. But then we're going to do sum x if x equals y. Then we want to print out matches. And then otherwise, we just want to print out our default statement. And for ease, we'll just print out default. So now we have sum 5, y equals to 5, and we're going to match on x. So when we run this, we see that it says it matches. So how is this working? So we're passing in x to our match statement, and then x is some value, and then x is in here as well, which in this case it is going to be 5. So if 5, which is referring to this x right here, equals y, which is 5, and then in this case we know that 5 equals 5, so we are able to execute this block of code. So now if I change this to 10, so x is going to be sum 10, then we anticipate 10 being printed out, which is exactly what happens. And then obviously if I put in 15 here, so we're not going to, this is going to be false, this will be false, well then we expect default to be printed, and that's what we get. So through the last few lectures we have learned about enums and pattern matching, which is a very powerful feature Rust has. And as I mentioned earlier, we were going to cover generics in the next section, so let's continue on with what traits and generics are. I hope you enjoyed this section and that you were able to complete this assignment based on the previous lectures. In this assignment, we wanted to create an enum called shape and provide the values of triangle, square, pentagon, and octagon. Then we need to create a method for this enum that returns the number of corners each shape has based on the type of shape. So for example, if we have a triangle, we will return 3, and then if we're a square, we will return 4. So the first thing that we need to do is create an enum called shape, and we need to give it some variants. So we are going to give it triangle, square, pentagon, octagon. Now we need to implement our method on the shape enum. And we're going to call it corners, and we need to have a reference to ourself, and then we know that we want to return how many corners we have, so we're going to return an I8. So now we are going to do a match on ourself, and if we are a triangle, we want to return 3. If we are a square, we want to return 4, and if we are a pentagon, we want to return 5. And then if we're an octagon, and since that's our only other case, we can use the underscore as our catch-all. Then we want to return 8 in that case. So now we will say let shape equals shape triangle, and we want to verify our results, so we will just print them out. So we will say shape dot corners, and now we can run our code, and we see that we have 3, so that's good. Let's do square. We got 4, so that's good, so we can assume pentagon will be fine. So now let's check octagon just to verify that we get 8, and now we have 8. So that is my solution to the assignment. If you have any questions, please feel free to ask them in the Q&A section.